Good morning. This is audience participation time. Good morning.
Good morning.
Yes, we're talking about reproduction today. It is actually afternoon, but I haven't eaten lunch yet. So I'm going to call it morning. I'm what's standing between you guys and lunch, actually, is what happens. So I must admit, I'm a little disappointed in one of my colleagues from the United States. Judd seemed to imply that nutrition was more important than repro. I'm here to say that that is, in fact, not the case. Repro is incredibly important. And what I want to share with you guys in this particular talk is some of the new technologies that have been developed with repro. How do we maximize those technologies to maximize fertility in a herd? So the first thing that I want to do is I want to try to get across a couple big picture items. I'm a physiologist, and I think one of the things that has really changed in the last 5 to 10 years is our understanding of the problem that limits fertility in lactating dairy cows. Because you can't really fix the problem until you understand the nature of the problem. And so it ends up that we have been able to improve reproduction a lot in these lactating dairy cows. So how do we integrate these reproductive technologies? So I put up there on the screen two different groups of animals. On the left we have lactating dairy cow, and on the right we have a non-lactating heifer. So just by a show of hands, which of these animals has the reproductive problem? So raise your hand if you think it's the cow. You think the dairy cow is the reproductive problem? You guys, this is your right arms. There you go. Very good. How many of you think it's the heifer? Okay, you think it's the heifer. You know, it's interesting, when we look at reproductive endpoints in these two different groups of animals in our different experiments, they are in fact quite different. And the thing that I would like to point out is that from a genetic standpoint, these two animals aren't very different at all. Okay, these animals are a little bit more advanced genetically, but they're not incredibly different from a genetic standpoint. Yet, when we look at these kinds of endpoints, and they're very different kinds of endpoints, we have duration of estrus, conception rate, pregnancy loss, multiple ovulation and twinning rate, which is an area that I'm really interested in and have done a lot of research in. If we look at the non-lactating heifer, if you go to the old reproductive textbooks, say the veterinary textbooks, what we would say is that the heifers, it's very simple, the heifers read the textbook. Heifers are doing everything that the reproduction textbook should say. They're in estrus for about 12 hours. They have conception rates in general that exceed 50%. They have relatively low rates of pregnancy loss, and they have low problems with multiple ovulations and twinning. So look at the lactating dairy cows in comparison. 7.3 hours estrus duration, less than 50% conception rates, relatively high pregnancy loss rates, and we do have an increasing problem with twinning in these lactating dairy cows. So what's the answer to this? Well, it's very simple. The cows read the textbook when they were heifers, and now they've forgotten everything that's in the textbook, right? So people have been searching for a long time to try to find some kind of a unifying hypothesis to try to explain all these differences. Is there something that's happening in these lactating dairy cows that would explain this difference? One of the things that we've found that's incredibly important, and I'm going to spend a lot of time talking about throughout my talks today, is this particular molecule. That's my favorite molecule in the female bovine. This just happens to be progesterone. And I would say even 10 years ago, I wouldn't have said progesterone is important as I think it is today with regard to various aspects of fertility. So progesterone is produced. This is an ovary. So on the ovary on the left-hand side here, we see a follicle. Of course, the follicle contains the oocyte. The follicle also secretes estradiol. When this follicle ovulates, it forms the corpus luteum. And the corpus luteum is the structure that produces progesterone. So I like to teach concepts via data. So the big thing you guys have to remember, the corpus luteum is what secretes progesterone. So I want to show you a bit of a conundrum with some data that were generated at the University of Wisconsin by my colleague Milo Wiltbank, one of his graduate students back in 2004. So I want you all to pay attention to the left-hand panel on this figure. This very hard-working graduate student, what he did was he ultrasounded cows, which are shown in this line, and heifers, which are shown in this line. So he was ultrasounding these cows and heifers every day from day 3 to day 14. And with ultrasound machines, we can very precisely measure the diameter using the digital calipers of the machine. And I just want you to think about what you notice here. Heifers have much smaller corpora lutea than lactating dairy cows do. And they're smaller by a large degree, not just a small degree. So remember, the corpus luteum is what secretes progesterone. Now I want you to focus on this panel. This is the same group of cows and heifers that were scanned in this graph. And now this is day of the estrus cycle, and what this graduate student did was collected blood samples. And what he found is that in heifers, they had higher levels of circulating progesterone than the lactating dairy cows do. So do you guys kind of see the conundrum in these data? Cows have much larger CL, yet they have lower circulating levels of progesterone. So how do we explain this? This is a hypothesis that I would present that really was developed by Milo Wiltbank, my colleague at the University of Wisconsin-Madison. And so to do this, I want you to all think about the highest producing dairy cow that you can think of. So everybody can get that cow pops right into your head, right? You think about your highest producing dairy cow. So here's a question. What can that cow do better than all the other cows in the herd so that she expresses this high milk production? What? Somebody said it. Yeah, she can eat. So nutrition is a little bit important, I guess I would say. So this is, I'm a reproductive physiologist. That's as good as I can draw a rumen for all of you nutritionists out there. So high feed intake is highly correlated with high milk production. So in other words, it's really hard to pull those two things apart. You can't have a cow that produces a lot of milk that doesn't eat. So the question becomes not maybe about milk production in and of itself, but what is the physiology of high feed intake? We're seeing feed intakes in these high-producing lactating dairy cows get to very high levels. And so the way that the physiology works, and this was some early data that was done in sheep, when you have high feed intake, and what they were doing was they were, in acute ways, they would feed sheep, and then they would fast sheep. And they were measuring progesterone in blood. So here's what happens. When you have high feed intake in a lactating dairy cow, you increase peripheral blood flow to the viscera, or to the gut. And because of the way that the blood flows through the body, the first place the blood goes after it drains from the gut is directly to the liver. And so by increasing feed intake, we increase visceral blood flow, we increase liver blood flow, and the liver is extremely efficient at clearing or metabolizing estrogen and progesterone from circulation. So I present this as a big idea. This is a hypothesis, but this idea is really what has driven development of the newer generation of some of the synchronization programs that I'll talk about in my talk. What this hypothesis would say is one of the problems with our high-producing lactating dairy cow, she has subnormal levels of estrogen, which would influence things like duration of estrus, number of mounts, and those sorts of things. And she also has subnormal levels of progesterone, which ends up affecting follicular wave dynamics. It could affect maintenance of pregnancy. It could affect oocyte quality. There's many different things that you can implicate. In fact, we've implicated this hypothesis in double ovulations and twinning. Cows that have subnormal levels of progesterone during selection of the dominant follicle actually will select two follicles, and they tend to double ovulate. So I'll talk about some of those things in my talk tomorrow afternoon. So if Milo's right with his hypothesis, I just want to put this in context. This is a very interesting graph that was put together by a scientist from, actually right up there, you guys see that? That is a Spartan helmet. This is from Michigan State. I'm a Badger from Wisconsin, so if I could get rid of that thing, I would, but I couldn't get it off the slide. Anyhow, Jack put these data together, and they're very interesting. What he looked at is he went back to USDA milk production records. He started in the year 1945. Now, my grandfather was milking cows in 1945. In 1945, the baseline milk production, I apologize, this is in pounds, 4,789 pounds. How would you like a herd of those cows? Right? It'd be like milking cows in Minnesota or someplace like that, right? So 4,789 pounds is our baseline, and what he said is from 1945, this is observed milk production. From 1945 to 1970, milk production doubled. From 1970 to 2005, milk production doubled again. And in 2015, we're at 22,498 pounds of milk. My grandfather could not have imagined in 1945 whole herds of cows given 22,000 pounds of milk. This is observed milk production, and what Jack said is, I'm just going to take the slope of that line, and I'm going to extrapolate it out. Now, of course, this is an extrapolation. This may or may not happen. And you can see what he shows in 2055, milk production will double again, and average milk production will be just under 39,000 pounds. Do you guys believe that can happen? So you're shaking your head. I will argue my grandfather couldn't imagine where we are today. We are on a pathway to dramatically increase production. Now, these dots represent kind of super cows. These are the cows in the Holstein breed. They're record holders. I think Neil showed a picture of the cow that I'm going to show. We have to add another dot. This cow, January 27th, 2017, broke the single lactation national milk production record. Of course, she is from Wisconsin, right? So this is kind of an average cow in Wisconsin. She gave a 365-day record of 77,480 pounds, which is over 35,000 kilograms of milk. The point I want to make with this slide, there is nothing natural about a dairy cow that's giving this level of milk. She has been genetically selected to give this amount of milk, and based on the liver metabolism hypothesis, she's going to have fertility issues. She's not infertile. She got pregnant. But her fertility is going to be affected because of this high milk production. Okay, now the reason I show this cow is because so many people come to me. I'm going to launch into some things about synchronization programs. Many people talk to me and they say, all I want to do is see my cow in heat, breed her, and get her pregnant. We all want to do that. But my argument here is that we've changed the hormonal milieu of the cow, and we've impaired this particular animal's fertility. Now, the good news is there's ways that we can restore fertility to these lactating dairy cows, and that's kind of the new aspect of the story that I'm going to talk about. Okay? People tend to not sometimes like the solution, but I can tell you that it works. Okay, so now that was just kind of my introductory comments. I want to launch into now, when I go to look at reproductive performance in a herd, I ask two questions. So the first question I'm going to look at is I'm going to ask the question, how and when are cows submitted for first insemination? So this is pretty simple reproductive biology. In order to get a cow pregnant, step number one is, you guys got to help me with this. You got to breed the cow. Right? I brought my 20-year-old daughter. We went through this, right, Leah, back in the day. This is reproduction, right? So I just want to simply look at how that's done. What is the plan on the farm? Some farms have good plans. Some farms have bad plans. They don't all get pregnant to first insemination. We're going to talk about increasing service rate, and then I'm going to get into this concept of fertility programs. So they don't all get pregnant to first service, so then we have to determine when are we going to identify non-pregnant cows, and then what is our plan for re-inseminating those cows? And if you can answer those two questions on a farm, you can get a good reproductive management program in place. One of the things I want you to go away with, there is not only one way to accomplish this. I've seen farms that do very well with reproduction using a variety of different strategies. So I'm not here to tell you exactly what you need to do, but I can tell you exactly kind of how things work and how things don't. Emil did talk about this, so I won't take too much time on this. The way that we measure reproduction in the US now is primarily through this metric. It's the 21-day pregnancy rate, really the way our computer programs are looking at this. And the only thing I'll say about this is that there are two other rates that determine the 21-day pregnancy rate. It's the rate at which we can inseminate cows. So obviously, the rate at which we can inseminate groups of cows every 21 days is going to limit or increase their reproductive performance because breeding a cow is the first step to getting her pregnant. Most people think about this, that service rate is probably the most, we have the most management effect on this service rate. The other half of the equation, though, of the cows that we breed, what is their conception rate? Now, I'm going to use the term pregnancies per artificial insemination. You'll see this throughout my talk. It's simply conception rate. But can we change conception rate? That's the real question. And that's the newer aspect of these fertility programs. We can not only improve the service rate, but we can push conception rates beyond what we ever thought was possible in these high-producing lactating dairy cows. So Emil talked about these visualizations. I just think that's really great. I've been using these kind of graphs for years. This is a visual representation of the plan of this farm for when they put semen into cows for the first time. Each red dot represents a cow. I drew a blue line at 50 days in milk because that's probably what this farm would say their voluntary waiting period is. And I drew a line at 100 days in milk because I could argue that it'd probably be a good idea to get cows inseminated for the first time before 100 days. So here's the question. In looking at this graph, how is this farm doing at getting semen into cows for the first time? Is this good or is this bad? Kind of not so good. The Romans would kind of do this thing or this thing, right? I'm going to argue that this is bad. This farm has very little control over their voluntary waiting period. By the way, why are they breeding cows early on this farm? Because they show a heat. I'll argue that we might not want to get a high-producing dairy cow pregnant at 35 days in milk. They won't all get pregnant, but the reason that they breed her is because of one very powerful motivating force. It's called fear. If I don't breed her, and I miss a couple heats, she's going to end up being one of these cows up here. So if I have to play that game, so the way I position this herd has relatively no control over their voluntary waiting period, and they don't have really a system in place by which they can inseminate cows for the first time before whatever day in milk that they want to set. About a third of their cows are going past 100 days without getting service for the first time. None of these cows can you expect to be pregnant before 100 days because they haven't been serviced. So this is a problem. This is what a lot of our herds look like. You can see the dates here back in the year 2000. So this is a detection of estrus problem. It's an expression of estrus problem. This is a cow problem. Okay, this is an expression of estrus problem. Data from the University of Wisconsin, milk production in kilograms per day. This is milk production in the 10 days immediately preceding estrus. So these cows were not synchronized. They were allowed to come into estrus spontaneously. You can see that the cows that are giving 25 to 30 kilos are in estrus for over 14 hours. But as milk production increases, the duration of estrus is starting to get truncated. Why would this happen? This is the quiz time in my talk. You guys are a quiet group. As milk production increases, feed intake increases. As feed intake increases, liver blood flow increases. As liver blood flow increases, we have more metabolism of estradiol, and we're starting to shorten the period of time that these high-producing lactating dairy cows are in estrus. So this doesn't really prove Milo's hypothesis, but it sure does fit with this. But this is a cow problem. So we have all kinds of estrus detection aids. We can chalk, we can paint. This was a picture when I was in Ireland on sabbatical. They used tail paint. But we get desperate. We get desperate when we try to catch these cows in heat. And so how many of you know that you can train dogs to detect estrus? Did you guys know that you can train dogs to detect estrus? So this is an actual experiment where they did this. I actually have a Labrador Retriever. So how many different colors of Labrador Retrievers are there in the UK? 3. What are they? Black, chocolate, right, and yellow. I'm going to argue there's 4. We got the black, the yellow, the chocolate, and we have the meth lab, too. And it just so happens that this is my black meth lab, Maisie, so she's kind of a crazy dog. But it's amazing. You can train these dogs. 4 trained dogs were 87.3% correct detection of estrus cows. But this is not addressing the cow problem. It's addressing kind of the detection problem. We have heat detection systems. This afternoon, I'm going to do a whole session on some of the work that we've done looking at these heat detection systems. They're very popular in the United States. People are buying these systems, and they're trying to use them. And so that's just kind of a shameless plug for my talk this afternoon if you're interested in what we've done with those. This is the big cow problem. This is a data set in which we had 5,818 cows, 13 different studies in 8 different herds. And what we did is we looked at what percentage of these animals are not cycling at the end of the voluntary waiting period. So all these cows had 2 blood samples taken at very specific times during a synchronization program, and we can calculate this number pretty easily. And the prevalence of anovulation was 23.3%, ranged from 7.3% to 41% across herds. But suffice it to say, that number comes up over and over again, and here's the bad news. I don't care how well you watch your cows for heat. You will never catch them all in heat. Never, ever. Because not all of them are cycling. And this, I think, is a mistake that people make when they buy the heat detection systems and try to rely on them 100% for submitting cows to an insemination. So this is a paper that was published in 1995, University of Wisconsin-Madison. This is Richard Persley, a good friend and colleague of mine at Michigan State University. Milo Wiltbank was my mentor for my PhD at the University of Wisconsin and is my colleague now. And these guys, basically, this publication came out a little over 20 years ago now, and they developed this particular protocol. It's called an Ovsynch Protocol. It uses a combination of GnRH and prostaglandin treatments, and what it did for the very first time was it allowed us to program cows to receive a fixed time insemination without the need to see the cows in estrus. This was an area of research that had been going on for maybe 30 years, 20, 30 years in beef and dairy cattle. The ability to synchronize animals without the need to see them in heat gives us a tremendous ability to increase the service rate. I could go to a dairy farm when this protocol came out. I could say, show me all your non-pregnant cows, and we can set up all those non-pregnant cows, and with 10 days, I could have them all inseminated with a similar conception rate to having to watch for 21 or 42 days to catch those cows in heat. The first way that I saw Ovsynch being used, and so these are actual data from actual farms in Wisconsin. So this is the same kind of a graph that I showed before. A little bit later in time, 2003 to 2004, voluntary waiting period is 45. And I like what Neil said. You know, the greatest thing about data is that you don't have to talk to a human being to figure out what's happening. Because I learned that farmers, they lied to me when I asked them what they're doing. Or at least maybe they didn't know exactly what they were doing. So 45-day voluntary waiting period. From 45 to 70 days, these animals are simply detected in estrus. But remember, you're never going to catch all your cows in estrus. So what they did is they said any cow that hasn't been inseminated by 70 days is automatically going to be enrolled into an Ovsynch protocol. There's obviously a problem. We can't catch her in heat. We're going to enroll her into an Ovsynch protocol. And you can see all these cows are inseminated for the first time to an Ovsynch protocol. How is this farm doing it at regulating their voluntary waiting period? Better than the other farm. How are they doing at getting semen into cows before 90 days? Way better than the other farm. One of the things that I would tell you, some level of synchronization will improve reproductive performance on almost every farm because of the anovular cow problem and the ability to inseminate 100% of your cows to estrus. So this was very common in the early days of Ovsynch. But research marched on, and this is a paper in 2001. This is a group down at the University of Florida. And what we know from physiology is that if I could choose a day of the cycle to start this Ovsynch protocol, I would choose day 6 or 7 of the estrus cycle. And so what this group said, to avoid the latter half of the cycle, we can treat these animals with 2 treatments of prostaglandin 14 days apart. And then 12 days later, we start an Ovsynch protocol. And lo and behold, we have a pre-sync Ovsynch protocol. I would say in my experience, going around Europe, South America, I was on a 10,000 cow dairy in China last December. This is probably the most popular protocol being used to submit cows for first service. When this group took the anovular cows out of the analysis, there was 23% of them, this protocol increased fertility or conception rate more than just a straight up Ovsynch. So this was kind of a first attempt at increasing fertility in lactating dairy cows. But an interesting thing happens. You know, we developed these protocols at the university in the ivory tower of academia, and then what you do is you release them into the wild. And that's when really interesting things start to happen. Okay, so what farmers did is they said, well, cows are coming into heat after this prostaglandin. We're going to breed those cows We call this cherry picking in the US. So we're going to, any cow that's going to show us an estrus after the second prostaglandin, we're going to breed. So we can set that prostaglandin at our voluntary waiting period. Traditionally, that's around 50 days. So this one's going to be at 36 days. This is going to be at 50 days. We're going to cherry pick off anything we can see in heat. We'll never catch them all in heat, and the rest will go through the Ovsynch part of the protocol. And there's the pre-sync Ovsynch program. There's the paper from 2001. And this is what a lot of herds now look like. Very typical of a pre-sync Ovsynch herd. They've got a 50-day voluntary waiting period. That's the second prostaglandin. They're catching maybe 50 to 60% of their cows in estrus, and they're breeding them, and the rest of them go on to the Ovsynch type of a protocol. So can you see what's starting to happen? We're taking and we're getting more control over when we put semen into cows for the first time. We've started to take this variation out, and we've started to squeeze it down. So one thing I will say about this program, it is an excellent system for putting semen into cows. It will not give you the highest fertility that we can get to first insemination. That's a really important kind of new concept. Great way to put semen into cows, but you will limit the fertility of your herd at first insemination by doing this. And the reason is that when we pull these animals out, I'll just go back to this. The animals that come into heat here are the ones that are set up to start Ovsynch at the right time of the cycle. If we pull them out and breed them, we lose the pre-sync effect. And that was really shown in, well, actually, before I get to that, this is a herd that I went to in Wisconsin. It's about a 2,000 cow dairy. One of the things I always tell people, you know, they always ask me, which program would you use? And I say, that's really an unfair question. The thing you have to do is ask the farm, what is your goal? Some farms, they want to have the highest preg rate possible. Some farms, they want to, in fact, maximize estrus and minimize timed insemination. So this is a herd, and they've set a voluntary waiting period of 50 days. They actually give the first prostaglandin at 50 days. They breed a lot of cows to estrus. 14 days later, anything that's not been inseminated, they breed those cows there. And in this herd, only about 15% of the cows make it to an Ovsynch type of protocol. And I just ran the numbers on the 21-day preg rate, if you're familiar with these kind of numbers. 21-day preg rate, 25%. That's an excellent preg rate. I would never go to this farm and say do something different. The point I want to make here is they're getting it primarily by forcing the service rate issue. Conception rates, look at these conception rates in the older cows, 35%, 43% in the first lactation animals. Overall, 38% conception rate. I think that would be considered a pretty good conception rate to estrus for high-producing lactating dairy cows. The other thing I'd mention, and I'll talk about this afternoon, is I would use a different protocol other than a straight Ovsynch for this particular group of cows. So the question that a group of researchers asked, what if we don't cherry pick? What if we just did 100% timed insemination to this particular program? So this is a group from Germany that did a meta-analysis. They took 3 randomized controlled studies. One of them actually was a study that I did that I'll talk about this afternoon. One is a study that Milo Wiltbank did, and one is one that was done in California. Good number of cows in the study. So they compared a pre-sync Ovsynch with cherry picking to pre-sync Ovsynch without cherry picking. And their conclusion, incorporation of AI to estrus during a pre-sync Ovsynch protocol actually decreased the odds of pregnancy to first insemination by 35% when they cherry picked. That's just the concept that these are fertility programs, and introducing estrus detection can actually decrease fertility to first insemination. So we had a lot of farms that adopted these different protocols, a lot of farms doing pre-sync Ovsynch protocols, but really the question that we had became, how do we maximize fertility to this particular protocol? Are there things that we can do to make cows more fertile? And we really asked the question, how does progesterone concentration during Ovsynch affect fertility? So we have lots and lots of data sets where we've collected blood samples at each of these time points. I want to focus on this one because we found that this is incredibly important. When you give prostaglandin, you want them to regress their corpus luteum, and you want cows to have very low progesterone at this point in this protocol. Cows that don't regress their CL have poor fertility to this particular program. For those of you that maybe have a veterinary background, the problem we have, we introduce some artificial problems when we synchronize cows like this. If they ovulate to this treatment of GnRH, which we want them to, we're trying to regress a CL that's just acquiring luteolytic capacity to that exogenous prostaglandin treatment. So we've kind of created a particular problem. So this is a data set that my grad student put together. There's 3,148 cows in this data set. Each of those cows had a blood sample at that last GnRH treatment. We stratified them by progesterone to very low to low. I would say that's pretty low, and this is very, very low. When we do this, there's always a cut point. And in this particular data analysis, that cut point is 0.4 nanograms per mil. And animals that have more than 0.4 nanogram per mil at that particular time are not fully regressing their CL, and you tremendously decrease fertility in those animals. The way we think this is harming fertility, how many of you have ever inseminated a cow? Okay, so what's the site of semen deposition? Where do you put the semen when you do AI? This is audience participation time. We don't have a lot of time. Exactly. We go into the uterine body. Where does fertilization take place? In the oviduct. So here's the question. How does sperm get from the uterine body to the oviduct? If you say it swims, I tricked you. Okay? Sperm does swim, but it's the female reproductive tract that does that transport, and it has to do it under a very low progesterone environment. So what we think is happening is in these animals that don't fully regress their CL, I mean, they're kind of regressing, but they don't fully regress. We're just stopping gamete transport. So we noticed that this was a particular problem, and really the question is, how do we fix that problem? And the way we fix that problem is adding a second prostaglandin. Now, I've jumped ahead. This is a double Ovsynch protocol, which I'll show you a little bit more about in just a few minutes. But rather than using 2 prostaglandins to pre-synchronize the cows, we use a full Ovsynch, which has its benefits. But I want to talk about the addition of this second prostaglandin, and I think some of you have kind of heard about that. When you do this, when you have 1 prostaglandin, the younger cows really regress their CL pretty well. 1 versus 2 prostaglandins isn't a big difference. It's the older cows that go from 37% to 45% conception rate. So that was kind of the linchpin. That was kind of the major, Emil talked about this rate-limiting step. In a synchronization protocol for the older cows, the rate-limiting step is getting that CL to regress completely. So this is a herd now that's on a double Ovsynch protocol. So how's this herd doing at getting semen into cows at the end of the voluntary waiting period? 100% timed insemination for first insemination. I completely understand that my experience with the UK veterinarians is that this may be something that isn't going to happen here. And I'm not telling you that it should happen here, but what I'm trying to tell you is why we have some farms that are doing this. It's because you get 100% of your cows inseminated within 7 days of the end of the voluntary waiting period. And I'll show you in just a minute. We can push conception rates to 50% or higher in our high-producing lactating dairy cows. So these are truly fertility programs. Now, what is the other thing you notice about the voluntary waiting period on this farm? See, this is the key, and I think Emil was getting to some of these concepts. Now that herds can get half of their cows pregnant at first insemination, which is something we never could do before, they're saying, we don't want to get half of our herd pregnant at 50 days in milk. And many of these herds are pushing voluntary waiting periods into the mid-70 range, and I've seen herds into the mid-80s and close to 90 days in milk at first service. But you have to do something like this if you increase your voluntary waiting period, because you have to control when you put semen into them, and you have to get very high fertility. I want to show you a recent study that we did. This is probably the most convincing data I can show that these protocols, particularly a double Ovsynch protocol as shown here with the second prostaglandin treatment, is in fact a fertility program. So what we did on this particular farm is we randomized cows to 2 different treatments for first insemination. We had a fertility program, which is double Ovsynch. The other half of the cows were randomized. This is really nothing more than 2 prostaglandins 14 days apart. We added the second prostaglandin just because it was here. You you dream up ways that reviewers could trash your article. So you try to do things that are kosher. And so we added it there. We also added a GnRH up front because we wanted cows to come into heat. We felt this might increase the proportion of cows that we found in heat. And these cows were inseminated, and the key is first insemination happened at the same day in milk range. So the first thing we can look at is conception rate. 39% conception rate when we bred these animals to estrus, 49% overall conception rate when we breed these cows to a double Ovsynch protocol. But conception rate is only half of the issue. Remember that we breed 100% of our cows. And this is what I want you to think about. Nobody is checking these cows for ovarian cysts or ovarian problems of any kind. 100% of the cows go through this protocol and we get half of them pregnant. All those problem cows are in that group. They're not pulled out of there. This group of animals, the service rate was only 78%. This was done with mostly tail chalk, but they also had a heat detection system. You'll never catch all of your cows in heat. So remember that preg rate is a combination of service rate and conception rate. So you'll see these numbers on the next slide. What I did was I just said submission rate of 294 and 284 cows, 100 versus 78, 29% advantage for double Ovsynch. Conception rate at first service, 49 versus 39, 27% increase for double Ovsynch over estrus. But then what I did is I said, let's adjust for the total number of cows we start with. Let's look at the proportion of cows that are pregnant after first insemination. 49% versus 30%, 64% increase for double Ovsynch. And then this is at the recheck at 63 days, 45% versus 36%. That's the conception rate then. The proportion of pregnant cows, 45 versus 28, 58% more pregnancies in the double Ovsynch group. This is why some farms are using these timed insemination programs to set up their cows for first insemination. It's a very powerful way to increase fertility, increase service rates, and get very high preg rates in these lactating dairy cows. This is just other data. Notice the first lactation animals in this study. Breed them to estrus, they're pretty fertile. You breed them to double Ovsynch, a little bit of an increase, but not much. Look over here at the older cows. Older cows bred to estrus, 31% conception rate. You put them on a fertility program, 44%. I did a calculation before. This is a big increase in fertility, particularly for those older cows. Okay, so let me just check my time here. How much time do I have? I have 15 more minutes.
Yeah.
Okay. Okay, so I've kind of quickly gone through these concept of fertility programs, ways to submit cows for first insemination. Want to quickly just go through how and when we identify non-pregnant cows and re-inseminate them. Why do we do non-pregnancy diagnosis? We do a non-pregnancy diagnosis not to identify pregnant cows, but to identify the non-pregnant cows. Okay, because then, you know, it makes you get this warm, fuzzy feeling inside. You go, oh, wow, that one's pregnant, good. But that's not why we do a preg check. We want to identify the non-pregnant cows, and we want to rapidly return those cows to an AI service. We have to take into account pregnancy loss. We have some really interesting data on pregnancy loss that I'll talk about in some of my other talks at this meeting. So we have different ways to detect pregnancy. There's direct methods. These are the older methods. We can palpate animals. This is one of our undergraduates at the University of Wisconsin. See how much fun we have with Repro? You never see nutritionists smiling like this when they're gathering fecal samples and things, right? So actually, this was palpation. This is an art. You know, this is an art that's been taught to veterinarians for many years. Really pioneered at the University of Wisconsin by this guy here, L.E. Cassida, back in the 1940s. I had to try this. It was so fun. You know, I saw this cow actually in Germany, and so, you know, you can see exactly what I'm doing inside of that cow when I do that. What's that? That is an embryo, and I have particularly affinity for that embryo. How are we looking at it? With what? We're using ultrasound. And so if you look up in this corner, that happens to be my wife. This is my son, actually. Ultrasound has really made inroads. And so this is what a lot of our veterinarians look like now. And it's really great because you've got these fashionable goggles that you can wear, and nobody else can look at what you're seeing. So they can't question your diagnosis, right? So you're out there, you're doing your thing with the ultrasound, and using ultrasound, we can look at this pregnancy loss. This is kind of a classic study where they started at day 28. If the cows were pregnant with an embryo, that was the baseline. And then periodically they would recheck these animals all the way out till calving, and you generate a pregnancy loss curve that looks like this. Now what I can show later this afternoon is there's a heck of a lot of pregnancy loss happening even before day 28. So this is just a picture of what we can see with ultrasound. But the point is, by about 70 days is the inflection point on that curve. The problem we have with early non-pregnancy diagnosis is we can make a lot of mistakes at this time period, and you have to do rechecks. You just have to do rechecks if you're doing these first preg checks. So most of our farms will do an early preg check somewhere between day 30 and 39. They'll recheck them about 4 weeks later, and they'll do a dry-off check. And when I look at reproduction in herds, I like to see those three different things. This is basically the pattern of return to estrus. We have a lot of herds, even now, that have bought accelerometer systems that will set up their cows for first insemination on a timed AI system for the reasons I said, for the high fertility and the service rate. And then this is the earliest non-pregnancy diagnosis you can do right here. Notice that most of the estrus activity is over by day 32. If they haven't shown an estrus by day 32, they're pretty much done. The other point I want to make, they're not all coming back into estrus at 18 to 24 days. There's a lot of extended cycles, and we have some very interesting data that I'll talk about on that as well. So what we'll do is we come in with a GnRH treatment on day 32. We'll breed these cows to estrus. We come in on day 32 with GnRH. Then we'll do a pregnancy diagnosis at the prostaglandin treatment. If they're not pregnant, they get the prostaglandin, and then these cows are re-inseminated. And so now we have kind of a system to deal with the cows that failed to conceive to that first service, either breeding them to estrus or allowing them to get to a resync type of a protocol. We have indirect methods. These are newer methods. hCG, often used in humans. However, unfortunately, primates and horses are the only eutherians that produce a chorionic gonadotropin. And of course, we have these early pregnancy tests in humans that are very accurate. And the reason I'm showing this is because people said, well, we can do it in humans, why can't we do it in cattle? And the reason we can't do it very well is because we don't have a homologous hormone to the chorionic gonadotropins. So let's just go on to this. This was back in 1986. This is pregnancy-associated glycoprotein, at this time called pregnancy-specific protein B. And this is just the profile of these pregnancy-associated glycoproteins in a group of 5 heifers that were pregnant. So that's throughout gestation. Notice they kind of don't come up until mid-20s. They come up and peak, and then they come back down again. That's really important for these early preg checks. So they have to be 28 to 30 days after insemination. It competes directly with ultrasound. They have to be at least 60 days post-calving to get all of this cleared out of the maternal circulation. So we've worked with these tests. They're simple ELISAs. They're very effective. You can see these are samples on day 20, 22, 25, 27. You can see this cow got pregnant. It turns blue. You don't need a reader to read this thing. You can just buy the plates and actually run the tests on farms. We've incorporated these tests into resync programs where they get a first insemination. We start the resync. We pull the blood sample. We checked it with ultrasound to see how accurate the PAG test was on day 27, and it actually was 95%. So these commercial tests for these pregnancy-associated glycoproteins are quite accurate. We did a large study comparing PAGs in milk versus blood, and just notice the biology of what's happening here is really unknown. The earliest you can check is day 25. They peak on day 32, so day 32 is an excellent time to use these PAG tests, but even in pregnant cows, they come back down and then go back up. So when you do these tests is pretty critical, and we have a lot of farms in the US now that are trying to use these tests, and I really focus them in on kind of day 32 as a time that I would want to do this. So the last thing I'll talk about here is just the resyncs. Notice at first breeding, 47% conception rate. This is a double Ovsynch herd for first breeding. This is at a time when they hadn't added the second prostaglandin. But that conception rate is a reflection of the double Ovsynch program at first breeding. Notice that the rebreeds, they drop precipitously in conception rate. And so a big part of my program over the last, I'd say, 10 years is, can we get fertility of those resynced cows up? And just for the sake of time, I'm going to skip ahead and just show you this. When we add that second prostaglandin into the Ovsynch protocol, we do have an effect on fertility in these resync situations. So 27% without it, 35% with it. We've also looked at incorporation of progesterone into the protocols. And the way we typically do this in an Ovsynch protocol is we'll put a CEDAR in, or a PRID, if you like, at the first GnRH. We pull it at the prostaglandin. And so we did a large study where cows either had exposure to progesterone or they didn't. And you can see if they didn't have a CEDAR, cows without a CL at that first GnRH treatment always have low fertility compared to the cows that do have a CL. That's just very typical. Notice that if they had a CL and they got a CEDAR, there's no benefit. So the bottom line is we don't want to put progesterone into cows that have a corpus luteum. It's really not going to do much for those animals. But for the animals that don't have a CL, we can dramatically increase fertility in these resync programs just by exposing them to progesterone at that time. Okay, so just to wind things up, I've got just a couple minutes. This is our University of Wisconsin dairy. We have we have 3 different locations where there are cows. This particular site has about 550 cows in these 2 barns here. I just have to show this off. This is our brand new manure lagoon. So we were out of compliance, so we had to build a multi-million-dollar manure lagoon there. And so this is the milking parlor. And what we did with this herd is we said, how high can we get the pregnancy rate? And really, this is the culmination of a lot of the things that we have done over the last 20 years, really. And just brace yourselves, because this is going to be no-holds-barred manipulation to see how high we can get conception rate and pregnancy rate. So this is the program for first insemination. It's a double Ovsynch protocol with the second prostaglandin. Everybody's going to get a timed insemination within 7 days of the end of the voluntary waiting period. And as you'll see, first service happens between 76 and 82 days in milk. This is what we put together to deal with the non-pregnant cows. It looks more complicated than it is. We come in on day 25. We set up with GnRH a week ahead of the herd check. The veterinarian will come out with an ultrasound on day 32, do the pregnancy diagnosis. The key to fertility to those second and greater breedings is simply categorizing the open cows as to whether or not they have a CL. If they have a CL, we finish the protocol. This is nothing more than an Ovsynch with the second prostaglandin here. About 85 to 90% of cows go this way. The rest of them, if they don't have a CL, we restart Ovsynch. We expose them to progesterone. That's really important for a number of reasons, including double ovulations and maybe decreasing the risk of twinning. And then we finish off that particular protocol. So that's the way that we run Repro. This is voluntary waiting period is 76 to 82 days. There's first insemination. Second insemination is here. Third insemination is in green. By 100 days after the voluntary waiting period, we've given our cows 3 chances to become pregnant. Right now, for the past maybe 2.5 years, we've been running a 21-day pregnancy rate over 30%, and that's adjusted based on a 76-day voluntary waiting period. But the thing I want to point out is the conception rate. We're averaging 50% conception rate. This is a 14,000 kilogram rolling herd average herd, too. It's a very high-producing herd. 47% conception rate on the older cows, 61% conception rate on first lactation animals. And so I just ran out number of times bred, and you can look at the percentage of animals that accumulate as pregnant. Within the first 3 inseminations, we have 90% of the cows pregnant. So by 180 days in milk, we've got 90% of our cows pregnant. If you're a cow on this herd, and you're not pregnant by the end of after your 3rd insemination, you're going to have what we call a career change. Those animals don't stick around very long, and I like the first speaker who showed those graphs where those animals tail off at the end and really skew these results. This sort of thing doesn't happen too much, although I will say when you do something like this on a herd, the one key to this program has a name. Her name is Sandy. She's the herd manager. So Neil was talking about compliance. Compliance is incredibly important, and Sandy makes sure that this gets done. So I asked Sandy, what the heck is going on with this cow? She's got 8 inseminations, so Sandy kind of fell in love with this particular cow. She wouldn't let her have the career change. But there's not too many cows that are going beyond that point. So we get cows very pregnant very quickly, and it's a very effective way to get these cows pregnant. So this is just to finish up. 21-day pregnancy rate in 2007 in the United States, 8,660 Holstein herds. The average of this distribution, 15.3%. That's where we were about 10 years ago with 21-day preg rates. I think only about 20% of the herds in this distribution had preg rates greater than 20%. So in a 10-year period, just 8-year period to 2015, you can see how that distribution changed. Median and mean now are 17.7 and 18.6. In this distribution now, 45% of the herds have greater than 20% 21-day pregnancy rates. And I would say that a 20% preg rate is a very low goal now. Most herds that aren't at 20 need to be at 20, and we're seeing more and more herds in these mid-20s to low 30% range. Notice they're not all there, though. Obviously, this is a normal distribution. We have good herds and we have bad herds. So with that, I thank you for coming to the talks this morning, and I'll try to answer any questions if we have any time. So, thank you.